calculation of empirical formula when the mass of CO2 and water is given. Because you can see the question at the board. Now, an organic compound contains only hydrogen, carbon, and oxygen when 1.46 grams of A bonds in excess oxygen, 2.79 grams CO2, and 1.17 grams water are formed. Calculate the empirical formula of A. Now, the first thing you need to know is that they have already given you the mass. So the mass of CO2 is given. So the mass of CO2 is given at the question, which is 2.79 grams. And the mass of water is also given to be 1.71 grams, right? Now, remember, they gave us these two masses. Now, all you need to do is for you to get the mass of carbon in CO2. And for you to get the mass of carbon, what you need to do is, in CO2, how many carbon do you see? One carbon. Of course, so you have one of the carbon all over the total CO2. So C all over CO2. Then you now times it by the mass given. This is bomb. Please pay attention. So you have to times it by the mass of CO2 given, right? So you have to times it by the mass of CO2 already given. What I'm saying is, what is the mass of carbon is 12. The molar mass of CO2, so you have carbon plus 2 oxygen. So this is 12 plus 16. So this is 12 plus 32. And this will give you 44, right? So the total mass, the total mass of CO2 is 44 grams per mole. So all you need to do is, there is 12 carbon in 44 grams of CO2. So this is 44 times the mass given. So for you to get the carbon, times 2.79. Whatever it gives you. Now, the same thing happens in hydrogen. In water, we have 2 hydrogen, not 1. Look at it, H2O. So you have 2 hydrogen in water all over the mass of water times the mass given, 1.71. So this is 2, because 1 times 2 is 2. And of course, the total mass of, the molar mass of this, if you calculate it, it should give you what? 18, right? Hydrogen is 2 plus 16, 18 times 1.71. Now, if you punch your calculator here, you should get here 0.76 gram of C, and then here it should give you 0.19. This is 0.19 gram of H. Now, so they remember in the question they only gave us the mass of CO2 and the mass of water. Now you have managed to get the exact mass of carbon and hydrogen. Now remember, they said it also contains oxygen. So once you have gotten the two, all you need to do, remember, an organic compound contains blah 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 when 1.46 grams of A bonds in excess oxygen. So all you need to do is plus these two values together minus subtract it from that one given in the question. So you have 1.46 minus 0.76 plus 0.19. Remember, I want to get the mass of O, the mass of oxygen now, right? So if you plus these two, you subtract it from what we're given, and what you will get is 0.51 grams of oxygen. Now, if you see in the question, we already have the mass of carbon, the mass of hydrogen, the mass of oxygen. Now we can solve the question immediately and everything will start flowing naturally, of course. Now, all you need to do right now is to construct your table. I want to clean that first one. Or should I come and clean here? Let me clean here. So should be copying by now. So let's construct our table. So you have carbon, hydrogen, oxygen. And then, of course, the mass of carbon is 0.76, the hydrogen is 0.19, and the oxygen is 0.51. Divided by, of course, the molar mass, which is 12, 1, 16. So whatever you get there, this will give you 0.063. Now, of course, this is 0.19. This should give you 0.032, right? Now, of course, we are going to divide by the lowest, right? So the lowest here is this, so divide by 0.032, 0.032, 0.032, and of course what you should get here is 2, 6, and 1, right? So from here you have your empirical formula, which is C2H6 and then O, right? Good. Now that is the question for A. They said you should calculate the empirical formula, which you already did. Now the B part is, if the molecular mass is 9.2, what is the molecular formula for A? Now, of course, you know how we used to do it. You know exactly. If you have watched a part 1 of my video, in short, solving this number B is an insult to you. Now, you can pause the video and immediately try to solve it out. It's not that difficult. Now, we said that the molecular weight is equal to empirical weight all times N, right? Good. Now, we want to calculate N first. So your N is the molecular weight all over the empirical weight. Now, the molecular weight here is 92.616. The problem here is that we do not know the empirical weight, but we can calculate it. So this place is 2 carbon plus 2 hydrogen plus an oxygen. And so this will give you 2 into bracket 12 plus 2 into bracket 1 plus 16. Now, punching that whole thing in your calculator straight away should give you 46 gram per mole. So this will give you 46 gram per mole. Now, dividing here by 46, 92.16, when you divide it by, what you will get is 2. Now, all you need to do is you come back again. Remember I said that the molecular weight is empirical weight times N, right? Now, for you to get the molecular weight, now, use the empirical. And our empirical weight here is C2H6O. Then you times it by 2. Multiplying everything is C4H12O2. And that is the answer. So you should get that. And that is the answer for this. So it's easy. If you are following my video, of course, this should be a child's play for you. Let's continue. .404 grams of an organic compound A gives on combustion 0.722 grams of CO2 and 0.294 grams of water. What is the empirical formula of A? Now, in this question, look at it very well. You can see they were not even talking about oxygen. In most times, the first example I did, they were talking about, they said hydrogen, carbon, oxygen. Here, no oxygen. They just said an organic compound. Now, in this kind of question, please don't say, okay, because they only said hydrogen and oxygen, I will just solve hydrogen and carbon, let me just solve the two. No. Immediately you get the mass of carbon, the mass of hydrogen, you have to add them together and then minus from the mass given for you to know if there is a mass of oxygen. Sometimes when you add the carbon and hydrogen together and you get 0 as the mass of oxygen, that means that the mass of oxygen is 0 there, is neglected. But when you add them together and subtract them from the main mass given, and you still have something, that means there is an oxygen there. So let's continue. Of course, you know how we need to do it. We used to do it. Pause the video immediately and solve. So this is solution. So in this solution, of course, you have, for you to calculate the mass of C is what? C all over CO2 times the mass given, right? Times the mass given. And so this is 12 all over 44 times 0.722. And then that of the hydrogen is, we have 2 hydrogen in water, right? Times the mass given. And so here is 218 times 0.294. Now, if you times them together, this should give you 0.1969, 0.1969, and then this should give you 0.0327. Now, we have gotten the mass of we have gotten that of carbon and hydrogen. We have to get that of the oxygen, right? So from the total compound given, you have to subtract to get that of the oxygen. I don't know what's wrong with all my pens. I think the Hamatan is affecting them. So this is, oxygen is 0.404 minus, you add this together, this is 0.1969, right? Plus 0.0327. And then the mass of oxygen that you will get is 0.1744. So right now we have the mass of hydrogen, carbon, and then oxygen. So let's do the needful. Let's do the needful. All we need to do right now is plot. All we need to do right now is our table, of course, and then answer will start flowing naturally. Now, at our table, you have carbon, hydrogen, and then oxygen. And then the mass of carbon is 0.969, and this is 0.03327, while the other one is 0.44. You divide by 12 here, you divide by 1, you divide by 16 here. And of course, this should give you a value of 0.0164, and this should give you 0.0327, and then this should give you 0.0109. Now, which of them is the smallest? Of course, the one that is smallest is the mass of the oxygen. So you come here and divide by 0.0109, 0.0109, 0.0109, and so this will give you 1, this will give you 3, and then this will give you 1.5. Now, of course, whenever you have a decimal under empirical formula, you have to multiply by a value till you have a whole number. So if we multiply this, that 1.5 by 2, it will change to 3, right? So multiplying everything by 2, multiply these values by 2, what you get here is 3, 6, and then 2. Therefore, the empirical formula is C3H6O2, and that is the answer. So please endeavor to solve other practice problems, endeavor to solve them.